Hello students, let us start our discussion about refraction through prism. Refraction through a prism. So let us assume that we have a prism. Prism is a transparent media which contains two triangular surfaces and three rectangular surfaces. So suppose that this is a front of the prism and this was appears as a triangular shape, and this one is a rectangular face, and at the bottom this was another rectangular face, and this one is also another rectangular face. So this vertex of the prism is treated as by a symbol A, B, and this was C. So if we place a prism on any base, then the angle, vertical angle, which inclines the two refracting surfaces or rectangular surfaces, that is known as prism angle. This angle was known as prism angle, or also known as refracting angle of prism. Refracting angle of prism. So suppose that we assume about incident light ray which is incidenting at any point P on the prism surface. Then this surface is assumed as incidenting surface, and this light ray, suppose that OP is the incidenting ray. This is incident ray, incident ray. So where this ray strikes the surface of AB of the prism, this point is known as point of incidence. This is known as point of incidence. Point of incidence. So if we draw a perpendicular line to the face of AB at this point, passing through this point, then this line is treated as the normal for this point. This is the normal. Suppose that this one is N1, and the angle made by this incident light ray with the normal will be expressed as the incident angle. This is the angle of incidence. This is angle of incidence, and this one is the normal. So we know that when light goes from rarer medium to denser medium, then it bends towards normal. So the direction of the incident light ray is in this direction, but when it enters from a rarer medium to the denser medium, then it bends towards normal and passes through like acquiring this path. Okay, hence the angle made between this refracted ray with the normal is treated as R. Suppose that this is R, or simply we can treat as R1 for this. So if this refracted ray after refraction reached at any other point Q, suppose that on the other rectangular surface of the prism, then at this point we can denote this point as the point of incidence, because ray is going from denser medium to the rarer medium. Okay, so if we draw a normal at this point with this face AC, then we get a normal at this point like this. Suppose that this normal is N2, and the angle made by this incident ray with this normal is treated as by R2. Suppose that and all these two normals are intersecting each other by any point E. suppose that, then what will be the direction of the emerging out of this ray after passing through the denser to rarer? We know that when light ray passing transmitting from denser medium to rarer medium, then by the property of refraction it must goes away from the normal. It means it does not go in the straight line direction, but it goes in a direction that has away from the normal. Okay, so suppose that this OS is the final emergent ray, this one is the emergent ray, and the angle made between the normal and emergent ray is treated as angle of emergent, that is E. This is angle of emergent. Okay, so if we draw the QS in backward direction, then we find it intersects the initial direction of the OP at any point. Suppose that this is D or C here F. Okay, so we are seeing that the light ray OP is entering on the first face of the prism, and the light ray QS is emerging out from the second face of the prism. So the direction of the incident of first ray is along OP, which on extending goes up to F, and also the light emerging from the second face of the prism is seemed as coming from the point F. Okay, so this one is the incident light ray direction, and this possesses the emerging out light ray direction. So total deviation, because this was the incident and this was emerging, so total deviation can be represented by a symbol delta. So this is the angle of deviation by which a light ray can bend from its original track after refracting from the prism. It means when a light ray entering into a prism, then after refraction it must goes through a emergent ray direction, that is QS. So what will be the total angle of deviation? So this angle of deviation delta must represent the total angle of deviation of the light ray after refracting from the prism. Okay, so this angle is treated as angle of deviation. Angle of deviation. So if we do some mathematical analysis at here, then we get what? Let us start our mathematical analysis. If we choose the quadrilateral A, P, E and Q, in quadrilateral A, P, E and Q, what? You are seeing that this N1 is the normal for this line. So the angle APE is equal to 90 degree, and also this N2 line is the normal for this surface AC. So the angle AQE or EQA, angle AQE is also equal to 90 degree. So as the property of the quadrilateral, the sum of the interior angles of a quadrilateral is 360 degree. It means angle A plus APE plus E plus AQE plus A. So since sum of interior angle of quadrilateral is 360. So angle of A plus angle of APE, that is what? 90 plus angle AQE, that is 90. First here angle E is plus 90 is equal to 360. So from here we get A plus E is equal to 360 minus 180, that is 180. So you got A plus E is equal to 180. So from here E equal to 180 minus A. This is equation number 1. Now if we choose a triangle PQE, now in triangle PQE or PEQ, the sum of the interior angle is always equal to 180 degree. So R1 plus E plus R2, so R1 plus R2 plus E is equal to 180, sum of the interior angles. Okay, so from here we get R1 plus R2 plus, if we put the value of E from here, then we get 180 minus A equal to 180. So we are seeing that 180 is same sign but opposite from the equal sign, so they will cancel each other. So from here R1 plus R2 minus A equal to 0. So R1 plus R2 equal to A. This is equation number 2. Now if we talk about the triangle PFQ, now in triangle PFQ, you are seeing that what will be the value of the angle FPQ. Then you will find that the value of FPQ, it means this angle, because the N1P and O is I, and this I is equivalent to the opposite angle, it means total. If we join this, increase this line in this direction and this one is in this direction, then all these two is equal to same, because I is equal to I, they are vertically opposite angle. So if the total value of this angle FPE is equal to I, then what will be the value of FPQ? This will be equal to I minus R1. So value of FPQ, that is I minus R1 plus second angle here. Similarly, if the total this angle is E, then total will be E, and this one is R2, so this will be equal to E minus R2. This will be equal to what? According to exterior angle theorem, we have got that if we elongate our single line of this, then the two farthest angle, the sum of the two farthest angle of a triangle is equivalent to the exterior of both these two. So this will be equal to del. Okay, so from here we can write it as what? I plus E minus of R1 plus R2 equal to del. Okay, so if we write it as equation number 3, then we can also write the value of R1 plus R2 as A at here. Then we get what? I plus E minus A equal to del. Equation number 4. Okay, now we have a special condition that is known as angle of minimum deviation. What is this? We know that if we do an experiment, then we find that when we are increasing this angle, then there is also an increment in the E. So if we draw a graph between incident and angle of deviation, then we find that when we increases the value of I, then we find that what will be the value of angle of deviation. We have find out a special graph like this. It means there is a special angle of incidence where this angle of deviation becomes minimum. If we increases the angle of I, then always the value of del is larger than its minimum value, and if we decreases the value of I from a special value, then is also greater than the smaller value. So there is a special case of the I for which this angle of deviation is minimum, and at this condition the angle of incident becomes angle of emergent, and this angle of refraction is just equal to the angle of this second incident. It means R1 equal to R2. This is known as the minimum deviation condition of minimum deviation. So if we write it as here, at condition of minimum deviation, at condition of minimum deviation, we get what? I is equal to E and R1 equal to R2. So if we let this equal to R, then if we place R1 equal to R2 in equation second, then from second what? This will be equal to R1 plus R2. It means R plus R equal to A. So from here we get 2R equal to A. It means R equal to A by 2. This is equation number 5. And from here, fourth equation, from 4, I plus E, it means I plus I, because I equal to E, and minus of A is equal to what? Del. Here del can be represented by a symbol del M, that is delta minimum deviation. Okay, so this will be equal to from here we obtain that I plus I, that is 2I is equal to A plus del M. So I is equal to what? A plus del M by 2. This is equation number 6. Okay, so if we apply the Snell's law at here, then we got what? According to Snell's law, we know that here the angle of incidence is I and the angle of refraction is R, because R1 is equal to R. So what will we obtain after applying the Snell's law? According to Snell's law, if the refractive index of this second medium is N2 with respect to air and N1 with respect to air of the first medium, so the refractive index of the second medium, that is prism, with respect to the surrounding, that is N1, so N2 by N1, that is N21, that is N2 by N1 is defined as sin I by sin of R. So this will be equal to sin of I. If we put the value of I from here, A plus del M by 2, A plus del M by 2 and divided by sin of R. So the value of R is A by 2. So this is equal to A by 2. So this is the formula for the prism. This is known as Prisma formula, and this is also known as refraction law for the prism. Okay, so here A is the prism angle, and we can state the two different conditions. One is known as thin prism, for which we assume that the value of the prism angle is smaller. So we can derive another formula for prism, that is also known as thin prism formula, if we take A is very small, that is 5 to 10 degree. Okay, so let us So let us put if the angle thin prism angle for thin prism. So for thin prism we can assume that A is very small. So for a small value of angle, sine of theta treated as theta for a small value of theta. A small value of theta. So if sine of A by 2 will be equal to A by 2 and sine of A plus del m by 2 will also treated as A plus del m by 2. So from there it means n2 equal to sine of A plus del m by 2 divided by sine of A by 2. This becomes n21 is equal to A plus del m by 2 whole divided by A by 2. So this is for thin prism. 2 and 2 will cancel each other. Here A by A plus del m by A. Okay, so from here AA, that is 1 plus del m by A. So transposing this 1 from this side, then we get n21 minus 1 is equal to del m by A. So from here we get what? Del m equal to n21 minus 1 whole into A. This is known as thin prism formula. This is known as thin prism formula, and this one was known as prism formula. Okay, this is prism formula. This is all about the refraction through a prism. In our next video we have discussing about the dispersion of light through prism. Okay, till now take care. Thank you.